Hello. In machine learning, a supervised learning technique called linear regression is the subject for today. Before getting into the subject, we'll see what is linear regression, what are variables, what is best fit line, how many types of linear regressions are there, what are evaluation metrics, and a program with its execution in Python. We'll discuss all these things today. Before we proceed, please like the video and subscribe my channel. Linear regression. It predicts the value of unknown data by using related and known data. It is like training a machine by giving some data called training data with correct answers and then asking the machine to predict the outcome for a new set of data by using the training data we have provided. So here machine tries to find a value for an input based on previous data it is trained on. And it's a straight line through a set of data points. If you see this graph, the straight line is the line of regression, which is surrounded by the most of the data points. And we have independent variable x, and then we have a dependent variable y, and these are all the data points. And this is a line of regression. We'll see what these are. Dependent variable, which we want to predict. Independent variable, which will help in predicting. For example, if we want to predict a student's exam score based on how many hours they studied. So hours will become independent variable, which will help us in understanding what score a student can achieve. Types of linear regression. Simple linear regression and multiple linear regression. In simple linear regression, we have one independent variable, x, and then the dependent variable is our target value to predict, that is y. And in multiple linear regression, we have the dependent variable y, and then we have multiple independent variables x1, x2, up to xn, that is, which is more than one independent variable. So what is best fit line? The best fit line is a straight line that most accurately represents the relation between independent variable and dependent variable. So this is a relation, this represents the relation between x and y. For example, for a given x, we have a predicted value p here, and the absolute value or the actual value y here. What is intercept? Intercept is where the relation between x and y starts. So this is here. This point is the intercept. So the distance from here to here is the intercept, and which is denoted as theta 0 or theta 1. And then we have a line of regression that is surrounded by most of the data points, and this is a linear regression. So the equation is y is equal to theta 1 plus theta 2 x, where theta 2 is the coefficient or slope of this line of regression, and theta 1 is the intercept. And if you see for this xy, we have a absolute value, the actual value provided yi at this point. But according to the line of regression, the prediction will come at this point of time for xi, which is pi. The difference between pi and yi is the random error for the prediction. And how to minimize this and how to evaluate this, we will see. Evaluation metrics. Mean absolute error. Mean absolute error measures the average absolute difference between predicted value and actual value. We have the predicted value and we have the actual value, and we take the difference of it and then we sum it up for all the values, all the training data that is given, and then we take average. So that is the mean absolute error. And the lower MAE, the lower mean absolute error value, the better performance of the model. The same way, mean square error. Mean square error is similar to mean absolute error. The only difference is we take the difference of actual and predicted values and we square it to remove the negative values. And then we sum up and then we do the average. same process. And the smaller the MSE, the better the model's predictive accuracy. That's about mean square error. And R squared. R squared tells us how well the line of regression fits the data. It shows how much of the variation in the output your model is able to explain. If there is any variation, and then how much of that variation we are able to explain is what R squared tells. And it is always in the range of 0 to 1. So higher the better. If it is near to 1, then the prediction accuracy is good. If you want more details on this evaluation metrics, we can do another video. Please comment it. I have a program in Python to execute. We'll do that next, but I will summarize what we are going to do in that program. The first step is importing all the libraries that is required for reading the training data and then fitting into the model and then evaluating it. Second part is load data from CSV file. So we use that library to load the data, and then we define what is independent and dependent variable in this data, in the loaded data. After that, we will initialize the model and then we'll fit it with the input and output. Output means actuals. And then we will evaluate the metrics, whether the predictions are all good, how much accurate it are. We will be doing that by the evaluate metrics. And then we will use the coefficients and intercepts that we have arrived from this initializing and fitting the model to predict the value for new input. So we'll give a new input which is apart from the training data, and then we'll ask the algorithm to predict the output of it. This is the training data I am going to input to the program. X1 and X2 and X3 are all the inputs, the independent variables, and then Y would be the actual values. So we provide all this data to train the model, and then we will give a different input, and then we will ask the program to predict the value. And the relation of y is equal to square of x1 plus square of x2 plus square of x3. So square all the individual values and then adding it will give the y value. Like we saw in the program summary, so we are importing the libraries pandas and sklearn linear model for linear regression. And as a second step, we are loading the data from sample CSV, which we saw just now, into the data attribute. And we are defining what is the independent and what is the dependent variables. So x1, x2, x3 are the independent and they are put into input attribute. Y is the dependent variable and it is put into the actual attribute. So we have values of y and we have values of x1, x2 and x3. Now we are initializing the linear regression to get a model, and then for this model we are fitting the input and actuals which we have took from the sample.csv. So this is the training data for us, and then model will predict the outcomes of the inputs based on the sample.csv training data what we have provided. So all those predictions are printed here, and then we evaluate the metrics. So from the model we take all the coefficients and then we also take the intercept, and here comes the evaluation, R squared evaluation, where we have a method in model to get the score of the R square, which will be derived by giving the input and actual. So that would be printed here, and then we have the coefficients and the intercept. Now we will use that on the new input. What is the equation? The equation is theta 0 plus theta 1 into x1 plus theta 2 into x2, so on. So for the prediction value, we have the coefficients from model, we got it from model, and we have the intercept. We have the intercept from the model itself. So we take that intercept and the coefficients and the input, and then we arrive with the predicted value. When I run this Python file, what we get is all the predictions first as I printed it, and then these are all the predictions which are pretty much matches with the 21 and then 14, 11. There is a random small error which